welcome back. I want to start off with a joke of the day coming from Cade Pierce. He poses the question, what did you learn in school today? The answer is not enough. I have to go back tomorrow. Well done, Cade. Let's talk about what we're doing today on Monday, November 16th. You're going to start with your warm-up. Last week I was really nice to you because I gave you all the answers in these videos. Hopefully you took the time to watch the video, because if you did not, I did not give you full credit on your answers. I'm laying it out as easy for you as I possibly can, so take advantage of that. Okay, so I will go over the warm-up, but I will not give you the answer. I'll tell you where to find it in the online textbook. Next, you're going to be completing your launch lab. I'll explain more about that later. And then at the very end of this video, I'm going to be explaining each of your words in detail to hopefully help you out in making your Jamboard. Speaking of your Jamboards, last week, a lot of you just hit the share button on Jamboard. Make sure that you hit the 3 dots next to the share button, to the left of the share button, and download that as a PDF, and then upload that to the Science Notebook post on Google Classroom. You can find that underneath the topic, which is on Monday. Today is Monday, so you see the Science Notebook post. Many of you use the Quizlet link that I put under that topic. So that is where you're going to be uploading the PDF version of your Jamboard. Also, talking about the Jamboard, you don't have to cram all the words into one of the slides. If you hit the arrow on the top of the screen on Jamboard, you can make a bunch of different slides. And when you download it as a PDF, I can see all of those. So if you just want to put one word per slide, that's perfectly fine. Okay. The more we work with it, the better off we will be with that. But just wanted to give you a few pointers on that. Let's talk about the warm-up. It says, what is the wave speed of the following light waves? I'm telling you exactly where to find it, which is in the blue box on page 121. So you need to give me 4 different answers here. You need to tell me the wave speed of a vacuum, of air, of water, and of glass. Okay, I've already made you use this wave equation. You do not have to do any math today. However, you do need to go to page 121 and look at the blue box in order to find that answer. I want to go ahead and explain this lab next, so stay tuned.
We're going to demonstrate refraction here, including a demonstration of total internal reflection. If I take this laser and shine it at this piece of plexiglass that's housing some water, you can see that I get here's the point where the laser beam hits the plexiglass. There's a reflected beam that comes over to here with angle of incidence equal angle of reflection. And then there's a refracted beam, and you can see that it's a little hard, well, you can't really see the incident laser beam here, but the beam bends when it enters the water. The water has a higher index of refraction than the air, and so the ray bends toward the normal direction being the perpendicular direction to the plane of the interface, and this is the plane of the interface, so the normal direction is this direction in here, and this beam is bent toward the normal direction. Then you can also see, after the beam enters the water, a reflection from the surface of the water right here, and then from the mirror on the bottom, etc., and multiple reflections.
All right, now that you have seen the model of what it is you would have done if we were in school normal, let's go ahead and answer these questions. So I pulled this up here on Google Classroom. You can just disregard this up here at the top because I've already done that for you. Essentially, I'm just showing you a video of a laser going through water. Now, you have already seen if we place a pencil in a beaker of water, how it's not going to look like it's in a perfectly straight line, which brings me to my first question. It says, compare the direction of the light beam before it entered the water to after it left the water. Did it continue to go in a straight line whenever you were watching that video, or did it go in a different direction? That's what I'm looking for that answer there. Now, the second part, it's going to be important that you listen to these directions because, of course, you can't write on the screen. I don't expect you to be able to type on a PDF. You are going to simply take a look at how I set up this question. So if I click out of here, you are going to take a look here that I already have it laid out for you. I already went over this first one where it says number 1. Number 2, here where it says content vocabulary, you can see across 1, 3, 4 and down 1, 2. So if I click back on the PDF of the lab paper, you can see here I'm asking you for these. So basically you're just going to be putting the word with the definition. Of course, I expect you to use your textbook in order to do that. Next, we're going to talk about vocab, and then we'll be done for today. All right, last but not least, let's hurry up and go through our vocab words for this week. You only have 5 of them, so your vocab quiz on Friday is going to be worth 10 points. I'm only going to ask you 5 questions, and of course, just like normal, you are going to be using each word only once. So let's talk about each of them. So let's take a look at light ray. So similar to what you just watched in your lab would be like the laser going through the beaker. Okay, that would be a light ray. Okay, so it's a narrow beam of light that travels in a straight line. The only way that it's not going to go in a straight line is if it goes through a medium like a liquid. Next, a light source, something that emits light. Again, think like flashlight, think like the sun, think the laser pointer in the video. Okay, that would be a light source. Where is the light coming from? Opaque. So now we're talking about the materials that the light is going to be traveling through. So opaque means a material that light does not pass through. So think like a solid brick wall. If I were to use a flashlight or a laser pointer and try to put that through that wall, it's not going to go through it because the wall is opaque. That light is not going to be able to travel through that. It's very different than sound. Okay, translucent means a material that allows most of the light that strikes through it to pass through but forms a blurry image. Think like a piece of paper. Okay, you are going to be able to see the flashlight on the other side, but it's not going to be nearly as clear as if that paper wasn't in the way. Okay, last but not least, let me move my head out of the way here. Transparent is a material that allows almost all light that strikes it to pass through and forms a clear image. So think like a window. If you were to go out to a car right now and you were to shine a laser pointer through that window, then you would be able to clearly see that light coming from that light source. Those are your vocab words for this week. Remember, you are creating a Jamboard. You are not going to be using the science notebook. You are going to put a word for each slide, and you may use pictures from the internet if you would like, if you don't want to just draw them out. That's your assignment for today on Monday. The next slides, you want to make sure that you have everything done.